In this video, I'll introduce the idea of a conditional distribution and a conditional expectation. So we have our usual setup. X and Y here are discrete random variables. They have some joint PMF. Think about a probability like this. The probability y is equal to 3 given that x is equal to 2 or something like that. Okay. It is the ratio of the joint PMF value, x is 2, y is 3, divided by the marginal PMF value for x, the probability x is 2. Okay. This is actually just an application of the definition of conditional probability that you know from our study of probability. If you think about that numerator, that joint PMF value, what is it for discrete random variables? Well, it's the probability that x is equal to 2 in our example and y is equal to 3. Okay? An intersection probability. And what's the denominator? Well, it's the probability x is equal to whatever value we're interested in, 2 in our running example for this slide. Okay, so this is just what I've done here is just translate those little f, notation for PMFs into the underlying probabilities. And then if you think of this as event B and this as event A, you'll see it's the probability of A intersect B divided by the probability of event A. Okay, so it's just conditional probability. That's all it is. Okay, we're calling it here conditional distribution or a conditional PMF. Okay, because you can imagine holding the x value you're conditioning on at 2, all right, and then saying, okay, when x is equal to 2, what's the probability y is equal to 1? What's the probability y is equal to 3? What's the probability y is equal to 4, etc., and dropping sort of different y values in right there. Okay. And that would give you, if you did this for all the different y values, it'd give you a valid probability distribution, a conditional distribution, all conditional on x equals 2, or whatever you happen to be using. All right. If you have that valid probability distribution of y, a conditional distribution, you could take the average of it, and that would be a conditional expectation or a conditional mean. Okay. And we write it like this. It'd be the expected value of random variable y, given that x is equal to, again, 2, if you just want to plug in a specific value. All right, how do we find expected values for a discrete random variable? Well, we take a sum of the values of that variable that are possible, weighted by the probabilities. The only difference with a conditional expectation compared to what you know about just the overall expected value of y is that the probabilities are conditional probabilities instead of unconditional probabilities. So instead of the case you've seen before, we sum over values of y times probability y is equal to that value. Here, we just use conditional probabilities following the fact that we want our expectation conditional on a particular value of x. Okay, so same idea as before in terms of expected value of a discrete random variable. It's just instead of the unconditional or marginal probabilities of y, we just use conditional probabilities of y to weight those different values of y.